Now we're going to go ahead and use some of our skills with composite area to develop the formulas that works both for kites and rhombi. So here I have a kite, and one thing I would like to do is cut the kite along one of the diagonals. And what shape do you get? You're going to get a triangle. Especially if you, you're always going to get a triangle. And you can see the diagonals are always perpendicular for both kites and for rhombi. So, what is the height and the base of the new figure? I'm not going to use the sides of it. I'm going to use the diagonals. So you can notice that the base is just this length, d2. And the height is half of this distance, half of d1. So I'm going to write down the area formula and substitute. Area is, for the yellow part of the triangle, is 1/2 base times height. So it's a half. The base is the diagonal 2, and the height is a half diagonal 1. I can combine the halves, which gives me a fourth, and I get this formula, 1/4 diagonal 1 times diagonal 2. But for any kite or rhombus, I'm going to have two of these triangles. So I need to multiply that by 2, which gives me the formula here for both a kite and a rhombus, a general formula, which is 1/2 diagonal 1 times diagonal 2. So I don't have to know the sides to calculate the area of a rhombus or a kite. I can just use the diagonals. So here we're going to calculate the area of the rhombus, and I know that those are going to be right angles there, and I'm going to use my knowledge of Pythagorean triples. This is a 5, 12, 13. So first of all, for a rhombus, both diagonals are bisected. So this is 5 and that's 5. This is 12 and that's 12. So I could have found the 12 by doing Pythagorean Theorem, but I know my 5, 12, 13 triangles, so that makes life easier. Then all I have to do is use the area formula, which is 1/2 diagonal 1 times diagonal 2. So I want this whole distance times that whole distance. All right? Well, diagonal 1 is 24 yards. Diagonal 2 is 10 yards. So once I put in my calculator, I get 120 yards squared. So this can be a real time saver when you are calculating areas of a rhombus or a kite. Now let's go ahead and practice converting. Now I want your answer in square feet. So I set up a proportion where my new area and my new units over my old area is equal to my new units over my old units, all squared. So I'm going to get a prime over 120 yards squared is 9 feet squared over 1 yard squared, and I cross multiply, and I'm going to get area is 1,080 feet squared. So some points for reflection. Why can I use half of the product of the diagonals to find the area of a rhombus, or a kite for that matter? And the reason is since they're perpendicular, they always create triangles, so we can use the triangle formula. And because one of the diagonals is already half, that ended up being the fourth, and you put them together and you're back to a half. What theorem could be used to find one of the diagonals given the other segments in the kite or rhombus? Well, you can use Pythagorean theorem. In fact, it seems we use it almost every lesson.